Greetings, I'm Squared here, and today we're going to talk about standard form. There are 3 forms, and this is the last of our 3. Standard form looks like this. Remember, the x and y are actual variables. They're always going to be x and y. And then a, b, and c are going to be numbers, but here is the thing, the special thing about standard form. A, b, and c always have to be integers, so you won't have any decimals or fractions. And a and b cannot both be 0, so you can have one of them 0. What happens when a is 0? Well, that means there's no a, because a times 0 is 0. 0 plus by would be by. So you wouldn't even see the x. If a is 0, you won't even see the x. If b is 0, you won't even see the y. So pay close attention to x is always first. The by is always next. And then you have a constant over here. C is a constant. So it's important that you know the order. And in some books, they tell you that A has to be positive. In this book, they're not saying that. So whether it's negative or positive, I'm not going to be picky about, but do know that if you're not using the book that we're using, that some people might say that has to be positive. So the first thing we're going to do is we're going to show you how to find the x and y intercept. So when something's in standard form, it's really easy to find both. And you need to be able to do that. So to find our x-intercept, it's important that that means where it crosses the x-axis. So this is our x-axis here. And a lot of people know it's the x-axis, but they forget what every point on the line. If every point on that line is the y is 0, because I didn't go up and I didn't go down. So like this point right here is 2, 0, and this point right here is 1, 0, 0, 0. Negative 1, 0, negative 2, 0. Y is always 0. So if y is always 0, whenever y is 0, I'm on the x-axis. No matter what point I plug right in here, if y is 0, I know I'm on the x-axis. So to find our x-intercept, we actually take out the y, we substitute it for 0. So we take out the y, put a 0 in, and then whatever we get, because y is 0, is our x-intercept. And then the reverse is true for this. It's the same thing, except I put a 0 in for x instead of y, because anything on this line has a 0 for x, because I didn't go left or right. So this line is the y-axis, but it's actually called x equals 0. This line is the x-axis, but its equation, I should say, it's not called x equals 0. Its equation is x equals 0, and this equation is y equals 0. So we're going to practice that a little bit in a minute, but I just wanted to show you the formula and what we do. The first thing I wanted to show you is, well, what happens when a is 0 and what happens when b is 0, and what does that look like? So notice a is 0 because there's no x, and 0 times x is 0. So how do you graph something like that? What kind of line is this? Well, first of all, what I do is I get y alone, so I would divide both sides by 3, and I get y equals 3. And so some people, they're like, I don't know how to graph that. Well, if you just think about y equals 3, well, pick a point where y equals 3. Okay, 1, 3. It says y has to equal 3, always and forever. Okay, pick another point. Okay, 2, 3. Pick another point. Okay, 4, 3. Okay, graph those points. 1, 3, 2, 3, 4, 3. What kind of line is that? What kind of line looks like that? Doesn't go up or down, has a slope of 0, while a horizontal line. So we're going to say horizontal line. That's what I was trying to get you to figure it out. So if you ever see a line where it's just y equals, that's a horizontal line. No x. So what about this kind of line? What if b is 0? Well, to get x alone, we divide by negative 2, so we get a negative 4. Well, what kind of line is that? Well, let's see. X always has to be negative 4, so go over 4. 1, 2, 3, 4. But you can go over 4 anywhere. Left 4 anywhere. X is negative 4 all along this line. What kind of line is that? We call that a vertical line. So keep in mind those special cases when a is 0 or b is 0. Remember, they can't be 0 at the same time. So if you ever see an equation like that, it's kind of nice if you don't go through all the process that you think you have to. You just say, oh, that's a horizontal line. Oh, that's a vertical line. So you got to kind of train your brain to remember that. Okay, let's talk about graphing lines that are in standard form. So the easiest way to do that, here's our steps, is we're going to find the x-intercept. We're going to find the y-intercept. We're going to graph them. We're going to connect the dots. Be aware of a being 0 or x being 0, horizontal and vertical lines. All right, so remember what we do to find the x-intercept. We've got to get y to be 0, so we substitute y. Now, I'm just showing you the long way. If I know that when I put a 0 in there, that just goes away, so usually I just cover it up and say, oh, 3x is 12, the x-intercept is 4. I do the same thing over here. Oh, when I'm trying to find the y-intercept, that's gone. So negative 2y equals 12. Oh, so the y-intercept is negative 6. That's kind of how I do it, but I'm going to show you the long way. Notice I plugged a 0 in for y. So I'm trying to find x. And that would be my alarm going off, for which I just shut off. Okay, so 3x equals 12, so x equals 4. I have now found my x-intercept, right? Because I have the x, so I'm going to go over on my graph 1, 2, 3, 4, and I'm going to make a little dot. Then I'm going to find my y-intercept. So I'll switch pens so you can see that. So now I'm going to make a 0 for x. So 0 for x. That goes away. I divide by negative 2, and I get y equals negative 6. So now I go to my y, 1, 2, 3, 4, 5, 6, and I connect the dots. And that is how you graph a line that's in standard form. Okay, let's try this one. What do you notice? I notice that a is 0, so that's going to be a horizontal line. So if you notice that, get y alone, right? Divide both sides by 4, you get negative 4, and so I say, oh, it's a horizontal line, and y is always negative 4. So all along this line, y is negative 4, so I just connect the dots. I think those are the easiest ones, but they kind of confuse people. I didn't need to find my y and x-intercept, although you'll see I don't have an x-intercept, but I do have a y-intercept of negative 4. Okay, let's try this one. So let's try the shortcut this time. So I'm going to find my y-intercept first. So I cover up the x because 0 times 8 would just be 0. So what is my y-intercept? My y-intercept would be negative 8 because negative 24 divided by 3 is negative 8. Now, to find my x-intercept, I cover up that guy. Negative 24 divided by 8 is negative 3. So negative 3, 0. Because when I put a 0 in for y, I just got 8 equals negative 24. Okay, so now I'm going to graph those two things. So 0, negative 8 is right there. Negative 3, 0 is right here. And to avoid squiggly lines, I'm going to graph with a ruler. And that is how you graph them. Kind of cool. I like that way. Okay, now we are going to write equations in standard form. So the first thing we're going to do is you're given an equation in either slope-intercept or point-slope form, and you have to change it into standard form. That's what we're going to do first, and then we're going to do it when you either have 2 points or a slope and a point. All right, so what is wrong with this? Well, first of all, I notice there's a fraction, and a, b, and c must be integers. So if they must be integers, I need to get rid of the fraction. So remember, we've been doing that for a while. To get rid of a fraction, we can multiply everything by the common denominator. So we're going to do that. So we get 2y equals x plus 14. And you see that the 2 and the 1/2 canceled, so it's just a 1x, but I didn't put the 1x. Now I need to get everything on one side. And usually it's on the left side. So I'm going to move x over. So I'm going to subtract x from both sides. Remember, x and 2y can't be combined, and we need both of them in order to have it in standard form. So my a is negative 1, my b is 2, and my c is 14. And this is how I go from slope-intercept form to standard form. And now I'm going to go from point-slope to standard. Again, I have a fraction, so I want to get rid of the fraction. I also need to get rid of the parentheses, but I like to get rid of the fraction first. So I'm going to multiply everything by 2. I'm going to multiply this side by 2, which means I'm going to have to distribute. But remember, out here, I'm only going to multiply the outside by 2. I'm not just like, see these parentheses where I put a 2 on the outside? There's a parentheses. I need to just multiply out here. And when I do that, the whole reason I did it, remember, is to get rid of the fraction. So I'm really going to be distributing a negative 3. So 2y minus 6 equals negative 3x. Negative 3 times negative 4 is positive 12. So the only thing I need to do is get x on the left side, and then, I shouldn't say the only thing, there's 2 things, and then I need to move this over there, the 6. So I'm going to add 6 to both sides, and I'm going to add 3x to both sides, and I get 3x plus 2y. That cancels out to be 0, and it equals 18. And that's my standard form. All right, now that's if you have an equation. You start with an equation, but now we're going to do it. What if you don't start with an equation? What if you have 2 points? So, and sometimes you could have point slope form first. So what we're going to do here is we're going to figure out what slope intercept form is and then change it to standard form. Here we're going to go to point slope form, which we've already done both of those. So it's kind of a review, but then we're going to take it one step further and take it to standard form. Okay, so first we're going to find our slope. So that means 7 minus 4, that wasn't negative. 7 minus 4, 6 minus a negative 3. So 7 minus 4 is 3, and 6 plus 3 is 9, so my slope is 1/3. And then I'm going to plug in my point, so I get y. I'm going to choose this point. Y is going to be 7, and my 6 is going to be my x. So I'm going to say y equals 1/3 of x plus b. Now, if that's really confusing for you because you don't remember, you didn't just review that, we have in class, but if you're watching from somewhere else, you might want to go back and watch the slope-intercept video. Because what we do is we just take our y equals mx plus b, which is our slope-intercept form. I should have wrote those up here. That might have helped. Let me remind you of what those are. So in case you haven't done that recently. Okay, so those are the forms. So what I did was I just picked an x and a y. I picked one of the points, and I plugged my x and y into the equation, this formula, and then I'm solving for b. So 1/3 of 6 is 2, and then I have to subtract 2 from both sides. So I get b equals 5. Once I have my b and my m, I can write it in slope-intercept form. So y equals 1/3 x plus 5. And then I'm going to change it to standard form. So how I do that is I have to multiply everything by the common denominator, because in standard form you can only use integers. So I'm going to multiply everything by 3. The reason I do that is to cancel my fraction. So I get 3y equals x plus 15. And then the last thing I have to do is just get x on one side. X on the side with the y's. So I subtract x from both sides. And when I do that, I finally get negative x plus 3y equals 15. So this part we've already done in class, and we're just kind of getting x and y on one side and getting rid of all the fractions. Okay, let's try this one. Again, we're going to find our slope. So here's my slope formula. So I have 8 minus 4 over negative 1 minus a negative 3. And so I end up with 4 over 2. And that is 2. So my slope is 2. And then I'm going to choose this point. Doesn't really matter which point you choose. This is x, this is y, this is m. I'm going to solve for b. So I say 8 equals 2 times negative 1 plus b. And, oh, I am so sorry. I am starting... sorry. No, we don't want to erase that. I was going slope-intercept form. I lost track of what I was doing. Let's get rid of that. Oh, I know. I'm just going to pick this point. I'm not too far off. And that slope. So it's y minus y sub 1 equals m times x minus x sub 1. There we go. That's our beautiful point slope form. Much easier than the other one. Two negatives cancel each other out. So now really we have integers. We don't have any fractions. So I just need to get rid of these parentheses and move the constants over to the right side and the x's over to the other side. So 2 times x is 2x and 2 times 1 is 2. So I'm going to add 8 to both sides. And then I'm going to subtract 2x from both sides. I like to do that at the same time so I don't do 2 lines. And I end up with negative 2x plus y equals 10. And that is in standard form. Now, the last thing is the special case when a is 0 or b is 0. And you notice that. If you're observant, it really helps. Do you notice that the x's are the same here? So let's say I didn't notice that. Well, then you'd find the slope first, right? So you'd say negative 2 minus 11 over 4 minus 4, and you'd get negative 13 over 0. Well, you can't divide by 0, so that tells you that the slope is undefined. And hopefully then that triggers that, oh, slopes that are undefined are vertical lines. Vertical lines have just an x. And so you'd say, oh, it's x equals, okay, well, what is the x? It's x. X is 4. So my equation is x equals 4. The easier way to do that is just to say, hey, look at the x's are exactly the same. Oh, well then x must equal 4. Because let's face it, if you graph that line, 4, -2, and 4, 11, it's a vertical line, right? So x is always 4 on that vertical line. So watch out for those special cases because sometimes they're a little confusing. So if you forget to be observant first, then you're going to get a slope of 0 or an undefined slope, and then you'll know, oh, those are the easy ones where it's just an x or just a y. Okay, good luck with standard form, m squared, sine